Have you ever noticed how some animals, worlds apart, look strikingly similar? Picture the giant anteater of South America, the aardvark of Africa, and the pangolin of Asia, all equipped with long snouts, sticky tongues, and powerful claws. Despite living continents apart and being unrelated, they share a remarkable resemblance. It's as if nature keeps reusing a winning design. This isn't coincidence, it's evolution's answer to a common challenge: how to raid the fortified cities of ants and termites. These insects are everywhere, building massive colonies that are tough to crack. Over and over, mammals from different branches of the evolutionary tree have independently evolved into ant-eating specialists. Scientists call this lifestyle myrmecophagy, and it's happened at least a dozen times since the age of the dinosaurs. From echidnas in Australia to sloth bears in India, the pattern repeats. Each is a testament to the power of natural selection, showing how similar problems lead to similar solutions. The story began over 65 million years ago, after the dinosaurs vanished, when mammals started filling every niche, including the one dominated by ants and termites. For a hungry mammal, these insects offered a year-round abundant food source, if only they could get to it. The result? Evolution's recurring theme, the ultimate anteater, written again and again in the details of claws, tongues, and snouts. Nature's copycats are a beautiful reminder of how life adapts again and again to the same irresistible opportunity. Why have so many mammals become anteaters? The answer starts with the ants and termites themselves. These insects are everywhere: rainforests, deserts, woodlands, conquering nearly every habitat on Earth. For every human, there are millions of ants. Their total mass outweighs all wild birds and mammals combined. Ant and termite colonies are permanent, reliable, and available year-round, a predator's dream. Unlike seasonal food sources, these insect cities are always open for business. A single army ant colony can have over 20 million individuals. A termite mound, several million. For a specialist, raiding a nest is like hitting the jackpot, tons of food in one spot. But these cities are well defended, powerful jaws, chemical sprays, and fortress-like mounds. Only those with the right tools, strong claws, long tongues, can break in. The reward? Access to a food supply few others can touch. This abundance and concentration of food have driven mammals to evolve into the perfect ant hunting machines. The ecological opportunity is so great, it's no wonder so many have joined the club of myrmecophagy. For those who can crack the code, the six-legged buffet never closes. That's why the world is full of ant-eating specialists, each shaped by the same irresistible feast. Let's meet the champions of ant-eating evolution. In South America, the giant anteater slurps up thousands of ants with its 2-foot-long tongue, no teeth required. Its relatives, the tamanduas and silky anteaters, hunt in the trees, perfectly adapted for life above ground. In Africa, the aardvark, last of its kind, digs through termite mounds with shovel-like claws. Pangolins, covered in protective scales, roll up like armored balls to fend off angry ants. Down under, the echidna uses its spines and beak to sniff out and dig up ant nests, while the numbat, a striped marsupial, devours termites by the thousands each day. Even the sloth bear of India has evolved a gap in its teeth to suck up termites like a living vacuum. Each of these animals comes from a different branch of the mammal family tree. Yet all have converged on the same solution, the ultimate ant-eating toolkit. Evolution's creativity shines in their diversity and in their striking similarities. These are nature's ant-eating all-stars. Despite their different origins, all these anteaters share a common toolkit. First, a long, slender snout, perfect for probing deep into insect nests. Second, a long, sticky tongue, often longer than their head, covered in spines and sticky saliva to snag hundreds of insects at once. Third, powerful front limbs with strong, curved claws for tearing into hard mounds and rotting wood. Many have reduced or no teeth, swallowing prey whole and relying on muscular stomachs to grind up insects. Thick skin, dense fur, or scales protect them from bites and stings. Some can even seal their nostrils to keep out dust and angry insects. Together, these features form the ultimate myrmecophagy toolkit. It's a masterclass in how evolution shapes form to fit function. How did so many unrelated animals end up so alike? The answer: convergent evolution. When different species face the same challenges, they often evolve similar solutions, even if they're not related. Think of sharks, dolphins, and ichthyosaurs, all streamlined for swimming, despite different ancestries. Anteaters are a spectacular land example. The last common ancestor of a pangolin and a giant anteater lived over 100 million years ago. Yet, both evolved long snouts, sticky tongues, and digging claws to exploit the ant and termite niche. Evolution, given the same problem, often finds the same answer. This isn't random. It's nature's logic at work. The recurring anteater is a predictable outcome of a specific ecological challenge. Convergent evolution reveals the deep logic behind life's repeating patterns. Why go to such lengths to eat ants and termites? Because they're the perfect meal. Packed with protein and fat, ants rival red meat in nutrition. Their colonies are vast and renewable, an endless, sustainable resource. Anteaters raid a nest, eat their fill, and move on, letting the colony recover for next time. Few animals can handle the defenses of ant and termite colonies, so competition is low. With the right toolkit, foraging is efficient. No chasing, just digging and slurping. This low-energy, high-reward lifestyle is a winning evolutionary strategy. High nutrition, abundance, sustainability, and little competition make ants and termites irresistible. For those who can crack the code, it's the ultimate buffet. That's why evolution keeps coming back to the anteater design. Is the story of anteaters finished? Not at all. As habitats change and food sources shift, ants and termites may become even more attractive. New pressures could push other mammals like foxes or mongooses toward a more ant-focused diet. Over generations, natural selection might favor tougher paws, longer snouts, and better digging skills. We already see opportunistic anteaters, bears, coyotes, even some primates, snacking on insects when they can. If their other foods decline, evolution could produce new ant-eating specialists. The next chapter in the anteater story may be just beginning. Nature's repeated solution to the ant problem is a testament to both the insect's success and evolution's creativity. So next time you spot an ant, remember the incredible array of creatures that depend on them. Which anteater is your favorite? The evolutionary menu is always growing.